Hi everybody. I just wanted to make a quick video going over this problem from the homework because I know it was one that confused a lot of people. And I want to use this as an example to illustrate a broader point about circuits where we have resistors in parallel. Okay, so spoiler alert, this circuit has these three resistors connected in parallel. Okay, and I'm going to explain to you why that's the case. So the problem was asking, calculate the current through the resistors. So how do we do that? Well, we could try to combine the resistors, either in series or in parallel, or some combination of those. But we have to figure out first how they're connected, right? And so looking at this thing, it's pretty confusing, trying to keep track of all the wires and the junctions and how everything lines up here. But there's a relatively simple way to see what's going on here, which is just to follow my advice of coloring the wires by their potential. Okay? So if I do that, right, everywhere that's connected by a wire here, okay, this is all going to be at the same potential. We can call this VA. And everything down here along this wire, this is all at the same potential VB. And then what we can do is we can look at what happens as we go across each resistor. Right? So going across A, we're going red to blue. Okay? And going across B, we go red to blue, and going across C, we go red to blue. All right. So across all three resistors, we have the same change in the potential. We have the same voltage. Okay. So right, and that's guaranteed because of the way they're connected. Because whenever I have points connected by a wire, I know all those points have to be at the same potential. So any situation like this, where I can guarantee that the voltage is the same across any set of resistors, right, of any number, then I know that that's a parallel connection. So it's not obvious how to deal with this circuit, but because I know it's parallel, right, I can redraw it. And I can redraw it like this. Right, so this is exactly the same circuit. Here, everywhere up here is at potential VA, and everywhere down here is at potential VB. Okay, and these are our resistors, A, B, C. Right? So these two are the same circuit. Okay, and so I can just combine this into one single equivalent parallel resistor, and then I can use that. I won't bother coloring it this time. I think you can see how that would work. I can use that to figure out what's the current here. Okay. Now you might be wondering, how would I know just by looking at this thing, right? Forget about, coloring the wires and, knowing what the potentials are or anything like that. If I just stared at this, right, how would I know that I'm supposed to take this thing? Okay, I don't know why these are connected here, but how would I know that I'm supposed to take this thing and turn it into this thing? And I'm not sure that you are supposed to know how to do that, okay? Or even can do that. Maybe you can do it. I'm not sure that I could do it, at least, okay? But what I know is, even if I can't look at the circuit and, disentangle it in my mind and turn it into something simpler, I can use the voltage and the current to think about what's going on in the circuit. And in particular with parallel resistors, again, if I can guarantee that all the resistors are at the same voltage, they have the same voltage across them, then I know that I have a parallel circuit. Okay? So, what does it mean to have two resistors in parallel? How should I think about resistors in parallel? Right, what it means is, again, I know that the voltage across them has to be the same. Okay, and practically the way I like to think about that is that, so voltage is the same. The way I like to think about that is that it means that if I look at the tops of the resistors, however we want to define top, right, so that we could be laying the resistors out horizontally and then it'd be, the left side or whatever. I just think about it as the top of the resistor, okay? So if the tops of the resistors are connected by a wire, so if there's any path between the tops, right, regardless of if there's a junction there, right, this is all at the same potential, call it V plus. And then if the bottoms of the resistors are connected, so if there's any path that only goes along a wire, right, connecting the resistors, the bottom, if the tops and the bottoms are both connected like this, then I have two resistors in parallel, because then their voltages have to be the same, right? If I go down across this resistor, I go from V plus to V minus, and same thing here. So resistors, or any circuit element, right? It doesn't have to be a resistor, are in parallel. If the tops are connected by a wire, and if the bottoms are connected by a wire. Okay. And again, it doesn't matter if I have junctions in between or anything else. I just can't have any circuit elements in between. So if I had this situation, say there's a battery here, this is no longer parallel, right? And I can see that because, okay, the tops of the resistors are connected, okay? But now I could try to connect the bottom of this resistor over here, right? And to get to the other resistor, I have to go through the battery. So there's a different voltage across this resistor than there is across this resistor. And so these are not in parallel. All right, let me look at one more example, also from the homework, which is this problem. Now this one is maybe a little bit less tricky than the previous one that we looked at from the homework, but I want to illustrate the same idea here, right? Looking at this circuit, how would you identify how the resistors are connected? Well, we know none of them are in series with each other because to get between any of them, we'd have to go through a junction. Okay, sorry about all the helicopters and background noise and such. But I can look in the same way. I can look at, coloring in the potential of the wires. So everything here is all at the same potential. Okay, here, this is some other potential. And then everything over here this is all at the same potential, right? So looking at each of these resistors, okay, well the 3 ohm resistor is not in parallel with anybody, but this one, and this one, they all have the same voltage across them, right? Going from red to blue. So these are all in parallel. Okay, and so I could redraw this circuit. Again, you might not be able to stare at this necessarily and do this, but once you know what the voltages are across the different resistors, you could just redraw it like this. Okay, and then from this point, now you got to pack up the circuit and get an equivalent circuit and then unpack it. But that's a different video. Okay. All right, so hopefully that was helpful for helping you think about when resistors are in parallel, and how do I uh, reorganize a circuit when I see that the resistors are in parallel. This is the reason basically that I suggested in lecture this whole thing of highlighting or coloring the wires, because it helps you identify situations like this, right? Where you might have some complicated series of connections, but you can show, because of the voltages, that they turn out to be in parallel. Okay. Thank you, everybody. I'll see you later. Have a good rest of your day.